it's not going to match what we have here, so I'm going to kind of erase this. Get the pen up there. All right, so basically, if you have a right triangle, and then if you know that one of the angles is 45 degrees, and you have a right triangle, that means the other angle automatically has to be 45 degrees. So we have this special type of triangle we call a 45, 45, 90, because it's got those three angles, 45 degrees, 45 degrees, and 90 degrees. So if I have this general triangle here with each side is x, basically I'd have x squared plus x squared. And before we call the hypotenuse this, we're going to figure out how we get this relationship. Let's just call the hypotenuse h for this. And does everyone see how x squared plus x squared would equal h squared? Yeah. So what's x squared plus x squared?
H squared.
Well, that's true. X squared plus x squared is h squared, but how can I simplify the left side alone? If I had 1x squared and then, or if you had 1x squared and I gave you another x squared, how many x squared would you have? 2. Yeah, 2x squared.
2.
Now let's get h by itself. How would I get h by itself? Unsquared, that's a good word. So h is by itself, and the square root of 2 we're going to leave alone. The square root of x squared is x. So that's where they got this. Or actually, what did I... Oh, because I'm calling the hypotenuse... I see what we're saying. I'm calling the hypotenuse the square root of 2 times x. So, I'm trying to think. If we had x for a side and x for a side, yeah, that's right. I just have to write an x square root of 2. Wanted to make sure I was doing that right. So, does everybody see how I have x squared root of 2 for the hypotenuse? So that's going to be your relationship. Whatever number you have here, you can multiply it by the square root of 2, and that's going to be your hypotenuse. But that only works for a 45, 45, 90. Let's look at another case, the 30, 60, 90 right triangle. And how we can show the relationship there is if I make a triangle with... So this is an equilateral triangle. In an equilateral triangle, all three sides are what? Equal to what?
Each other.
Which is the number...
45.
Not 45, 45, 45. It's 60, yeah. So this angle is 60 degrees. And then let's divide this in half. If I divide this angle up here in half, what do I get for this angle here? 30 degrees. And this is going to be a right angle because it's dividing we're going to assume it's a right angle. It's the height of the triangle. So this is kind of where your 30, 60, 90 triangle comes from. It's like half of an equilateral triangle. So the way we can figure out this is if I say each side is, we're going to call it 2x to make it easy on us. 2x for this side. And if each side is 2x, what does that make each half down here? Like, what would this, from here to here, what would that length be? If the whole thing is 2x, what would half of it be? Yeah, just x. So then this would be x. So each side is 2x. So let me write this, just the half triangle so you can see. This is your 60, your 30, your right angle. So you've got 2x. You've got x, and now we can use the Pythagorean Theorem because let's call this A for altitude or height. So basically a squared plus x squared equals 2x. That should be equals. Equals 2x squared. So a squared plus x squared equals 4x squared. So what would a squared equal? What would both sides... How would I figure out what both sides equal here? A squared... I would subtract x squared from both sides. So x squared minus x squared cancels out. What's 4x squared minus x squared? 3x squared? Good. And then how do I get the a by itself now? Square root. So a equals the square root of 3x squared, which is the square root of 3 times x. We're going to write that as x radical 3. Let me scroll up so everyone can see there. So this a here we can replace with x radical 3. So the special relationship here is that if I know this side is twice the length of this side, and this side is square root of 3 times the length of this side, the shortest side. So let's put that into practice for a couple examples. Let me get out of pen mode for a second. Oh, that works. So if I have a 45, 45, 90 right here. So I have, if this side is 8, that means that this side is also 8. So let's figure it out the old way to make sure we get the right answer. So if we were to, does everyone see why I could say this side is 8? Because of remember how your opposite angles, if your opposite angles are equal, that means the opposite sides are equal. So since this is 45 and 8, then we can say this is 45 and that's 8. So the old way we'd say 8 squared plus 8 squared. I shouldn't say the old way, but using the Pythagorean Theorem, we'd say 8 squared plus 8 squared equals x squared. So 64 plus 64, 128 equals x squared. So x should equal the square root of 128. Square root of 128. What is it? 11.3. Good. So we're going to put x is 11.3. So that's how we'd find it using the Pythagorean Theorem. But we can, hopefully this is a shortcut, we can kind of see how these are related. Remember, if this is x, this is the square root of 2. This side is going to be the square root of 2 times x, or x times the square root of 2. So if this is 8, we take 8 times the square root of 2. And what's that in your calculator? So the same answer. So see how, because we knew this was a 45, 45, 90, we were able to do something in one step that could have taken us like 3 or 4. So let's try a couple more here. In number 2, we're given the hypotenuse. So we know that the hypotenuse is x radical 2. So if the hypotenuse is x radical 2, what does that mean x, this side over here, has to be? Not necessarily half, but it's just going to be, because because this hypotenuse is x multiplied by the radical 2, so if this represents x radical 2 would have to be 3 radical 2, so x is equal to 3. Does that make sense? Or all right, let's try this one here. In this case, x, what would x equal in this case? It's the hypotenuse. Very similar to what we did in number 1 at the bottom.
You take 4 plus 4 squared plus...
Well, we don't have to do this part. This was the Pythagorean theorem. We're only concerned with this right here. Yep. All you got to do is 4 radical 2. And if you want to put the decimal in, what you'll need to do for the homework, I guess unless you do it on paper. But so what do you get for? Did anyone get an answer for that? Yeah, 5.7. So I think we got the 45, 45, 90s down. Any questions on those 3 problems? Okay, then let's look at let's see, some 30, 60, 90s here. And this proof that I went through with you is right here at the top, by the way. I guess I didn't realize that was in the notes already. But let me just do this. Find x and y. All right, so remember our relationship for a 30, 60, 90. You have it. Let me just redraw it for you. We said so 30, 60, 90 is a little more complicated because you have to remember that your long side is x radical 3, the short side is x, and the hypotenuse is 2x. So looking down here, we'll kind of keep that up there for reference. If my short side is 1/2, what's that make my hypotenuse? Well, your short side is always half of your hypotenuse. So if the short side is 1/2, what does that make the, I guess you can't see if I...
It makes the other side the long side.
Yeah, it makes this is the long side. So we're going to find that is... Okay, I'll just kind of tell you on this. Well, oh, that's the bell. Oh. We'll finish this up tomorrow.